Yeah, in today's class, we'll discuss about the types of optical fibers. Yeah, optical fibers are classified based on materials, based on number of modes, based on refractive index profile. Out of these three, one of the very important thing is based on refractive index profile. Okay. In the last class, already we discussed about based on materials and based on number of modes. Okay. In today's class, we will discuss about based on refractive index profile. In any optical fiber, the cladding has uniform refractive index. Okay. However, the refractive index of core is either remain constant or vary in a particular way. See, in any optical fiber, basically we are having three types, three layers. One is the inner layer is core. Around that we are having cladding, and around that we are having the buffer. Okay, that we can call jacket also. Okay, in that any optical fiber, the cladding layer having uniform refractive index. That means in that cladding layer, wherever you can find the refractive index, that is the uniform. But however, the refractive index of core is not uniform. That is either remain constant or vary in a particular way. Okay, how that is changing? That curve represents the refractive index profile. Okay, the curve which denotes the variation of refractive index with respect to the radial distance from the axis of the fiber is called the refractive index profile. That means how the refractive index of core is changing, okay, along the radial distance from the axis. That is called refractive index profile. The curve which denotes the variation of refractive index with respect to the radial distance from the axis of the fiber is called refractive index profile. Based on Based on this refractive index profile, optical fibers are classified into two types. One is the step index fiber, second one graded index fiber. Okay, based on variation in the refractive index of core and cladding, the optical fibers are classified into two types. First one step index fiber, second one graded index fiber. Okay, now we will discuss first about step index fiber. In step index fiber, the variation in refractive indices of pore and cladding varies step by step. Okay, that's why we are calling this is a step index fiber. Okay, the variation of refractive indices of pore and cladding varies step by step. This type of fiber is known as step index fiber. Okay, based on refractive index profile and the number of modes, further step index fiber is classified into two types. What is they are? First one is step index single mode fiber, step index multi mode fiber. Okay, now here in this topic we are going to discuss about all these three topics. First one is step index single mode fiber, second one step index multi mode fiber, third one graded index fiber. Okay, first one is the step index single mode fiber. Okay, this is the diagram of the structure of step index single mode fiber. You can observe single mode means inside the core only one light ray is traveling. There is only one mode of transmission. The basic structure of the step index single mode fiber is shown in figure. This is the diagram. Okay, it consists of thin core of uniform refractive index of a higher value. See, this is the core and the black color one is the cladding. See, first you can understand the how we can call step index optical fiber here. Here the refractive index of core is uniform. The refractive index of cladding is also uniform. Okay, the refractive index of cladding is uniform in any type of optical fiber, but the refractive index that may constant or that may vary. In case of step index optical fiber, the refractive index of core is also uniform. Okay, when we are moving from core to cladding at the interface, the refractive index suddenly changes. Okay, see already we know the condition in any optical fiber, the refractive index of core is always greater than refractive index of cladding. Okay, here also the refractive index of core is greater than the refractive index of cladding. But here the refractive index of core is uniform, cladding is also uniform. But when we are moving from core to cladding at the interface, the refractive changes suddenly. That is in the shape of step. Okay. This core is surrounded by a cladding of uniform refractive index lesser than that of the core because the refractive index of core is always greater than refractive index of cladding. So in case of this step index single mode fiber, what are the diameters of core and cladding? A typical step index single mode fiber, sorry, a typical step index single mode fiber has a core diameter of 5 to 10 micrometers and an external diameter of cladding is 50 to 125 because here we are seeing only one light ray. That's it, the diameter of core is small, that is 5 to 10 micrometers, and the diameter of cladding is 50 to 125 micrometers. Okay, here the refractive index changes abruptly at the core cladding interface or boundary. Okay, its refractive index profile takes the shape of a step. That's why we are calling step index optical fiber. Due to a small core diameter, only a single mode of light ray transmission is possible, as shown in figure. Because of small diameter, we can send only one light ray. Okay, right. This is the basic introduction of step index single mode fiber. Next characteristics you can check. Here you can observe this diagram. This blue color circle is the core and red color circle is the cladding. The diameter of core is 5 to 10 micrometer. The diameter of cladding is 50 to 125 micrometer. See, you can check this diagram. The refractive index of core is uniform. This straight line represents the refractive index of core is uniform. And this line represents the refractive index of cladding is uniform. But when we are moving from core to cladding, that is the shape of a step. That means that suddenly changes. Okay, this is the optical fiber axis. From here, we are moving towards the core cladding boundary. The refractiveness of core is uniform up to entire core. And when we are moving from core to cladding, the refractiveness changes suddenly. Okay, and it has a thin core diameter typically of about 10 micrometers. Okay, because we are sending only one light ray, the diameter is very small, and its numerical aperture is also very small because we are sending only one light ray. The numerical aperture, that means light gathering capability at the output, that is also small. It supports only one mode in which the entire light energy is concentrated, that is moving in only one mode. Okay, right. Next, because of a single mode of propagation of light, there is no signal loss due to intermodal dispersion, because there is no chance of collision colliding the light rays. What is the meaning of intermodal dispersion? Due to optical power loss due to collision of light rays. But here we are sending only one light ray. There is no chance of loss due to intermodal dispersion. And finally, this is having a higher bandwidth than multimode fiber. Okay, if there is no loss, then bandwidth is higher. Okay, here there is no loss due to intermodal dispersion, then automatically bandwidth is higher. If more bandwidth, we can send more data at a time. Okay, the advantage of this one is it has a very high rate of data transmission capacity. Because there is no loss, we can send more data, no degradation of the signal. Okay, there is no chance of intermodal dispersion, there is no degradation of the signal. About 80% of optical fibers manufactured are of this type. At present, whatever optical fibers we are using, out of all, 80% of optical fibers are made with the step index single mode. Disadvantages: the first disadvantage is the manufacturing and handling of this type of fiber are very expensive. The reason is, see, we have to make a core with the diameter 5 to 10 micrometers. With that small diameter, making core is not easy. That's why that is expensive applications. Okay, this type of fiber is used in undersea cable for long distance communication. Okay, it is used in particularly long distance communications we are using. That is in undersea we are using. It is used in submarine cable system also. It is used in long distance telephone system also we are using. And second one is step index multimode fiber. See, this is the diagram for step index multimode fiber. We are seeing more than one light ray. If you observe this diagram, inside this core we are having three light rays. One, two, three. Okay, there are number of collisions between those light rays inside that core. Okay, the geometry of normal cross section of a typical step index multimode fiber is shown in figure. This is the diagram. Its core has much larger diameter, which makes it easier to support propagation of a large number of modes. Compared with single mode optical fiber, this multimode optical fiber core diameter is larger because here we have to send more number of light rays. Okay, and a typical, now you can check the core diameter and the cladding diameter. A typical step index multimode fiber has a core diameter from 50 to 200 micrometers, and an external diameter of cladding is 100 to 250 micrometers. Compared with single mode fiber, these values are very large because here we have to send more than one light ray. It has core material with a uniform refractive index and a cladding material of lesser refractive index than that of the core, because here both two refractive index are uniform, but compared with the core refractive index, the cladding refractive index is less. There is sudden increase in the value of the refractive index from cladding to core. Okay, actually when we are moving from cladding to core, the refractive index will increase suddenly. When we are moving from core to cladding, the refractive index decreases suddenly. Okay, okay, this is the core and this is the cladding. When we are moving from core to cladding at the boundary, the refractive index increases suddenly. When we are moving from cladding to core, the refractive index changes suddenly at the boundary. Okay, there is a sharp increase in the value of refractive index from cladding to core. Thus, its refractiveness profile takes the shape of a step. Because of larger diameter of the core, the propagation of many modes within the fiber is possible. Because more larger diameter, then we can send the more number of light rays. This is the diagram. Same almost whatever we have seen in single mode. This blue color circle is the core and black color circle is the cladding. Our diameters you can observe here. And characteristics, if you check, it has large core diameter because we are sending more number of light rays. And the bandwidth, if you observe, it has low bandwidth. The reason is there is a loss due to intermodal dispersion. That also we will check. It has a low bandwidth, and light is passed into multimode fiber is LED. Generally here whatever light we are using, that is a LED, light emitting diode. And it has larger numerical aperture in the order of 0.3. The numerical aperture of this single multimode step index optical fiber is 0.3, and it has high attenuation. That means losses are more because we are sending more than one light ray. There is chances of optical power loss due to intermodal dispersion. Advantages: since LEDs we are using here, okay, since LEDs are used as the source of light, they are easier to operate. LEDs have longer life than laser diodes. Actually, compared to laser diodes, LEDs having the longer lifetime. Okay, thus making them more suitable in many applications. And compared to lasers, these are less expensive. They are less expensive and require less complex circuitry. And it is easier to couple the fibers. If the diameter is more, then it is easier to couple the fibers. Disadvantage is they suffer intermodal dispersion loss. Already I told, here we are sending more than one light ray. There is chance of collisions between the light rays. Due to that, we are getting the intermodal dispersion loss. Okay. Next, if you observe the bandwidth, it has having low bandwidth. If there is loss, then automatically bandwidth is also low, and data transmission is less efficient. Okay. Applications wherever low bandwidth is required, in that we are using these are optical fibers. They are widely used in data links which require low bandwidth. Okay. And last one is graded index multimode fiber. In this fiber, the refractive index of core varies radially from the axis of the fiber. Okay, see, in case of step index fiber, the refractive index of core is uniform, the refractive index of cladding is also uniform. But in case of graded index fiber, the refractive index of core is gradually changes from optical fiber axis. Okay, from optical fiber along the optical fiber axis, the refractive index is maximum. When we are moving from that axis towards core cladding interface, the refractive index gradually decreases. In this fiber, the refractive index of core varies radially from the axis of the fiber. The refractive index of core is maximum along the optical fiber axis, and it is gradually decreases towards core cladding interface. Thus, it is called graded index fiber. The geometry of normal cross section of a typical graded index fiber is shown in figure. Next slide, we will observe the diagram. And the typical graded index multi-fiber has a core diameter just like multi-mode step index fiber, because in graded index we are having only multi-modes. Single mode is not available here in this graded index. A typical graded index multimode fiber has a core diameter of 50 to 200 meters and an external diameter of cladding 100 to 250. And the refractive index of core is maximum at the axis of the fiber, and it is gradually decreases towards the core cladding interface. Okay, the refractive index profile is shown in figure that we will check in next diagram. The light ray propagation for this fiber is shown in figure. And if the diameter of the core is high, the intermodal dispersion loss must be high. Generally, we are sending more number of light rays, there is chance of loss due to intermodal dispersion. But here we are minimizing that. Okay, because of the gradual decrease in the refractive index of the core, the intermodal dispersion loss is minimized. See, if you check the diagram, here we are having total 4 light rays. Okay, and we will compare first these 2 light rays. This is the first light ray and this is the second light ray. Both the light rays started at the same point, and again they meet at the same point. But compare with their travel distance, the second light ray travel long distance compared with the first light ray. Then how that is possible? Okay, and how that is meet at the same point at the same time? The reason is that where the first light ray is traveling, in that place the refractive index is more. Where the second light ray is traveling, the refractive index is small. See, this is the optical fiber axis. Along the optical fiber axis, the refractive index is maximum. When we are moving along the radial distance, the refractive index gradually decreases. Okay, at the where the first light ray is traveling, the refractive index is high, and where the second light ray is traveling, the refractive index is low. Okay, that's why the second light ray traveled fast compared with the first one. Here we are, by using this concept, we are minimizing the losses due to intermodal dispersion. And characteristic, if you check here, this inner circle is the core and outer circle is the cladding. And if you check the curve here, okay, in case of step index, the curve is a straight line because the refractive index is uniform. But here the refractive index is not uniform. That is maximum at the optical fiber axis, and from the optical fiber axis, when we are moving towards core cladding interface, that is gradually decreases. That's why we are getting a curve here. Okay, it has a large numerical aperture. Here, wherever you are using multi-mode, in case of multi-mode, numerical aperture is large because light gathering capability is large. In case of multi-mode optical fiber, because we are sending more number of light rays, and it has intermediate bandwidth. Okay, in case of step index single mode, bandwidth is high. In case of step index multi-mode, bandwidth is low. But in case of this one, we are minimizing the intermodal dispersion. Due to that, the bandwidth is intermediate, and it has low attenuation. Attenuation is less, and that means we are minimizing the losses due to intermodal dispersion. And here the source we can use laser or LED, any source we can use. Advantages: intermodal dispersion is reduced with this type of fiber. By using this graded index multimode fiber, we are minimizing the losses due to intermodal dispersion. It is a high quality fiber and has good bandwidth. Compared with other fibers, it is a high quality fiber and bandwidth is also good. Disadvantage: the first disadvantage, it is most expensive of all type of fibers because we are making core by changing the refractive index. Okay, that is not easy thing, that's why it is most expensive, and its fabrication is also difficult. Coupling of fibers and light source is difficult. Coupling is also not easy because the refractive index changes, coupling is also difficult. See, by changing that refractive index, we have to make 5 to 10 micrometers is very difficult. That's why single mode here not possible in graded index. Applications: it is widely used in intracity trunks between central telephone offices, and it is used in medium distance applications. Okay, particularly in case of step index single mode, we can use for long distances, and step index multi mode we can use for short distances, and graded index multi mode we can use for medium distances. Okay, this is about the types of optical fibers based on refractive index profile. And next we will check the applications of optical fiber. As fibers are very flexible, they are used in flexible digital cameras. Okay, in digital cameras we are using, and fibers are used in mechanical imaging. Okay, that is for inspection of mechanical wells in pipes and engines of rockets, space shuttles, and aeroplanes. Also we are using these fibers. Okay, fibers are used in medical imaging, medical fields such as endoscopes and laparoscopes. Also we are using this optical fibers. Okay, for medical imaging. Okay, they have to check the what happened inside that our stomach. Okay, they will send one wire, that is optical fiber. Through that optical fiber they will send this LED or laser to check the our stomach. Okay, fibers can be used under sea communication. Just now we have seen step index single mode fiber, we are using this submarine system, undersea communication. And fibers are used in military applications such as aircrafts we are using, ships also we are using, in tanks also we are using, etc. And nuclear testing applications use these optical fiber phase sensors and transducers. Okay, these optical fiber phase sensors and transducers we are using in nuclear testing applications. Okay, fibers are used in public utility organizations like railways, TVs, transmissions, etc. Okay, almost in all fields we are using these optical fibers. Fibers are also used in LAN systems of offices. See, whatever internet we are using, that is fiber communication system. Okay, fiber optic system. Okay, in LAN systems of offices, industrial plants and colleges, etc. we are using fiber optical communication system. Okay, and these fibers are used in telecommunications such as voice telephones, video phones, telegraph services, message services, and data networks. That means in communication system also we are using. See, in military, in defense we are using, in medical systems we are using, in education system we are using. Okay, in almost in any government sectors. Okay, in all private sectors we are using these optical fibers. Huge number of applications for these optical fibers, and these are some of the other applications. See, in medical field where we are using, in defense or government where we are using, in data storage we are using, in telecommunication we are using, in networking we are using, in industrial or commercial where we are using. Okay, you see in this slide just I have given generally, but here I have separated. Okay, by medical field, by defense, by data storage, by telecommunication, by networking, by industrial or commercial application. Okay, these are the applications of optical fibers. Okay, thank you.